Hello students, welcome to Sreenath. In this video, we are going to discuss the 9th chapter in the 7th class math, that is rational numbers. Okay, my name is Karthik Nune. We are creating videos on all subjects from class 6 to class 8, and those videos are 100% free and are available in this present channel. So please do subscribe our channel and also like and share our videos. So what is the chapter name? The chapter name is rational numbers. Okay, in this present chapter we are going to discuss what are the topics we are having, what are the concepts we are having in this chapter. Basically we are having the almost 7 topics. Okay, we will discuss each topic in detail. In the beginning we are going to overview of all the chapter, what is there in the chapter, how many pages it is having, and what where the concepts are located, all those. After that we will discuss each topic in detail. Okay, students, and further we will have a summary of the whole chapter. In this present video we are not solving the problems. If you want the problems to be solved, especially the problems in the exercises to be solved, please comment below so that we will upload the videos on exercises. Okay, now we will start this session. Okay, now we are entering into the overview. Basically we are having 7 topics. The first topic is what are rational numbers. So what are rational numbers and what is numerator and denominator in the rational numbers, we are going to discuss about that. And what are equal and rational numbers, all that comes under the first topic. In the second topic, positive and negative rational numbers. There are positive integers and negative integers. In the same way there are positive and negative rational numbers. And the third topic is rational numbers on a number line. How to represent the rational numbers on number line. That is about the third topic. And the fourth topic is the rational numbers in standard form. So basically what is the standard form and what are the conditions to be for a rational number to be in standard form. We are going to learn about that in that fourth topic. And the fifth topic is comparison of rational numbers. How we will compare the rational numbers. And the sixth topic is nothing but rational numbers between rational numbers. So what are the rational numbers in between the rational numbers? We are going to find out those. And the next topic, what is the topic? That is the seventh topic, is operations on rational numbers. What are the basic operations? That is addition, subtraction, multiplication, all those. This is the seventh topic. That is the last topic we are having. So basically after that our chapter has completed. So this is the overall overview of the whole book, a whole chapter. Okay, now we will start our discussion on each topic detailedly. Now before starting the first topic, we are having the just have the general introduction. Basically up till now what we have learned about natural numbers, whole numbers and integers. So now in this chapter we are going to learn about the rational numbers. Okay, why we need rational numbers? Basically if you want to, until now we have discussed about the integers. There are positive integers, okay, positive integers plus 3 and minus negative integers minus 3. So we need negative integers, we need positive and negative integers. Why? That means suppose if from a point to the right, from a point to the right is there any house, it is at a distance of 3, then we will represent it as plus 3. And if there is any house or school which is left to that point at the distance of 3, we represent it as minus 3. Why? Because means if we represent it also, if you represent this point also with plus 3, then these both will be same and we will be confused. So for that reason, if you move from a right to one point, you take positive, and if you move from left from one point, it will be negative. Okay students, in the same way this is about positive integers and negative integers. And the same way, suppose if you are on the sea level, suppose if you are at the height of 750 meters from sea level, then this can be represented as the 3/4 of the kilometers. What it is? It is the basically 1 kilometer is having 1000 meters. So in that way you can represent it as the 3/4 kilometers. So if you want to represent the downside of 750 meters, how we will represent it? That is negative 750 meters, that is minus 3/4. For that reason there are some situations we will get into this type of fractions. Okay, this type of fraction. So we call these fractions, and we will need rational numbers and fraction type numbers for many cases in our life. So for this reason we need rational numbers. Now we are going to discuss each topic in detail. Now we are going to discuss each topic in detail. The first topic we are going to learn is what are rational numbers. It is the first topic, rational numbers. Rational numbers. Okay. So what is the definition of a rational number? Basically, a rational number is defined as the number that can be expressed in the form of p by q, where p and q are integers and q not equals to 0. So any number in the form of p by q is called a rational number. And what are the conditions? P and q are integers. P and q are integers. Okay. And what is the another condition? Another condition is q not equals to 0. This type of numbers which are satisfying these conditions are rational numbers. For example, take 2 by 3. It is in the form of p by q, numerator p by q, 2. Okay. And next condition is p and q are integers, so 2 and 3 is also integers. Next thing is q not equals to 0, so the denominator q value 3, which is not equals to 0. So it is a rational number. Why? Because it satisfies the three conditions. So can you what is the next can you guess another rational number? Yes, easily 5 by 4 or 3 by 7. All these fractions are rational numbers. Why? These are in the form of p by q, and these are satisfying, and these are and these numerator and this p and q are the integers, and the denominator and the q not is equal to 0. So can you guess any other real rational numbers? If you guess, comment below what are the different rational numbers you guess. Okay. This is about rational numbers. Any numbers which are in the form of p by q are the rational numbers. Next, what is about numerator and denominator? Basically, we are talking about p by q form. Until now we discuss integers, whole numbers, natural numbers. In any case we didn't find a dash like this, and one is on the upside and one is on the downside. It is the new one to us. So we call the upper part as the numerator. What it is? Numerator, which means which is on the upside, and we call it the down part, which is the number which is in the down part we called as the denominator. We call that place as denominator. So in the numerator there is p, in the denominator there is q. So fastly, without wasting, fastly comment below what is there in the numerator. Fastly comment below what is there in the numerator and what is there in the denominator. So without wasting time, what is the numerator in this fraction, in this fraction? You have to comment below fastly. I am giving you 2 seconds. Sorry, I am giving you 5 seconds. You have to write the numerator and the denominator in this fraction. 1, 2, 3, 4. Time's up. Okay. If in this fraction 2, which is in the upside, it is the numerator, and 3, it is in the downside, it is the denominator. In this fraction 5 is the upside, it is the numerator, and 4, which is downside, it is the denominator. And this fraction 3, which is on the upside, it is the numerator. 7, which is on the downside, it is the denominator, students. So this way, in this I hope that you understand about the numerator and denominator. So rational numbers means nothing but which are in the form of p by q form. And another condition is those p and q must be in integers, maybe positive or negative. And another thing is q must not be equal to 0. So and next one is what is about numerator and denominator. Which is on the upside is numerator, which is on the downside is the denominator. Okay, students. And now what are equivalent rational numbers? So basically we have discussed what is rational number. Now what is equivalent rational numbers? When did we say the two rational numbers are equal? Okay, so for that okay, let us take some examples. A rational number can be written with different numerators and denominators. For example, consider the rational number -2 by 3. So basically one rational number can be expressed in different forms with different numerators and different denominators. Basically, when we divide this, when we multiply numerator and denominator with the same value, same non-zero integer, then we will get different numerators and different denominators of the same integer. For suppose -2 by 3, it is equal to, now we are dividing, now we are multiplying numerator and denominator with 2. So 2 into 2. So what is the answer? That is minus 4 by 6. So this rational number is equal to this rational number. So basically here numerator and denominator are different, but both these rational numbers are equal. Then how, sir? But why, sir? Means if you cancel out the common factor, which is 2 in this, then you will get this form. Suppose it can be written as minus 4 into 2, 6, 3 into, sorry. It can be written as minus 2 into 2, 3 into 2. So 2 will be cancelled. Then what is the remaining? The remaining is the minus 2, 3, which is our rational number. So basically one rational number can be written in different forms with different numerators and denominators. How one rational number can be written in other forms means you have to multiply both numerator and denominator with the same number, with the same non-zero integer. If you multiply both the numerator and denominator, here you have multiplied both the numerator and denominator with the same non-zero number, which is 2, then you will get another rational number, but it is having different numerator but different denominator, but it is the same rational number. So how you can equal? So basically in this way rational numbers will become equal. So one rational number can be having different forms and it is equal to so many numbers. It is having different forms with different numerators and different denominators. By multiplying the numerator and denominator of a rational number by the same non-zero integer, we obtained another rational number equivalent to, we are getting another rational number. It is not a point, but that is equivalent to given rational number. Okay students, so that is about first topic. We have completed the first topic. Students. Now we are going to start the second topic, that is positive and negative rational numbers. What is the second topic? Positive and negative rational numbers. Positive and negative rational numbers. Okay, then if you consider it, so basically we are having positive integers. For simplicity I am writing it as plus. Positive integers and negative integers. Okay, in the same way we are having positive rational numbers and negative rational numbers. So what are positive rational numbers? Means suppose if both numerator and denominator of the number are positive integers, then it is a positive rational number. Suppose 2 by 3. So it is positive integer. So this is a positive rational number. So without wasting time, give me some more positive rational numbers in the comment section. Positive rational number. Okay. Can you give another positive rational number? Very simple. The only condition is numerator and denominator must be integer, must be positive integer. What it is? Positive integer. So 3 by 4, it is a positive integer. Another thing is 5 by 7, it is also positive integer. And another thing is 10 by 33, it is also positive integer. Why means numerator and denominator both are having same positive, both are positive integers. So this is about positive rational numbers. So positive rational numbers contains both numerator, both positive integers on numerator and denominator. Then what is negative integers? Negative rational numbers. What are negative rational numbers? Negative rational numbers. Okay, what are negative rational numbers? So basically whenever numerator is negative and denominator is positive, so basically negative integer, numerator is a negative integer and denominator is a positive integer, we call that as the negative rational number. Example is minus 3 by 5. If you consider it, the numerator is negative integer, denominator is positive integer, then this fraction we called as negative rational number. Very simple. What is the negative rational number? If numerator is negative and denominator is positive. Numerator is negative integer, denominator is positive integer. Then we can call that as negative rational number. Can you give me some more examples? Very simple. Minus 10 by 33. Simple here. 10 by 33. Here we are writing the minus 10. Only condition is the negative integer on the upside. And minus 2 by 3 we can write it also. So all these are the negative rational numbers. That's it, students. We have completed that second topic also. We are entering into the third topic, that is third topic, rational numbers on number line. How we will represent rational numbers on number line? Basically, we know how to represent integers or number line. So it is the number line and these are the integers. This is the 0, 1 positive integers on the right side. From the 0, positive integers will be right side. From the 0, negative integers will be left side. These are minus 1, minus 2, minus 3, minus 4, like that. So in the same way, if you want to represent the positive rational numbers on the number line, they must be on also the right side to the 0. If you want to represent negative rational numbers, they must also be negative left side to the 0. And if you observe in the case of integers, the successive integers having equal distance. Okay. Now we will now if you want to represent the 1 by 2 on the number line, on this number line, how you will represent? So basically the value of 1 by 2, we know that is between the values of 0 and 1. So we have to represent 0 and we have to represent a 1 by 2 rational number in between 0 and 1. So here is the 0, here is the 1. So 1 by 2 will be this. Because it is a positive rational number, so it must be on the right side of the origin. So 0. So it 1 by 2 is here. It is exactly half distance, halfway from the 0 and 2. In the case, how we will represent minus 1 by 2? If you want to represent minus 1 by 2, same thing you have to do is you have to go from, it must be in between 0 and it is between minus 1 to 0. So one more thing in the case of a number line means, if you move right side to the number line, the right side numbers are always greater than the left side number. So 3 is greater than the 2 and 4 is greater than the 3 and 1 is greater than the 0. At the same time, 0 is greater than the minus 1 and minus 1 is greater than the 2 and minus 2 is greater than the 3. So but in the case of positive, but you think that in the case of positive integers 3 greater than 2, but in the case of negative integers minus 3 is less than minus 2. So which is bigger? Minus 2 is bigger, but in the case of positive integers 3 is bigger. Why? Because means it is all due to the sign, negative numbers. So when you go left to the number line, all values will be decreased. When you go right to the number line, all values will be increased. So in the similar way, if you have positive rational number, it must be represented from right side to origin 0, and if you have negative rational number, it must be represented left side to 0, and negative rational number is always less than the positive rational number. Okay, this negative rational number minus 1 by 2. So one more thing is, if you consider the integers, if suppose 1 is on the right side, minus 1 is on the left side, and the distance between 0 and 1 is equal to distance between 0 and minus 1. They are in the same time, the distance between 0 and 2 is equal to distance between 0 and minus 2. Okay, in the same way, the distance between 1 by 2 and 0 is equal to distance between minus 1 by 2 and 0. So it is between 0 and minus 1 and 0. So it will be here, which is minus 1 by 2. So we called it as B and we called it as B. Suppose it is A, suppose it is B. So in this way we can represent rational numbers on a number line. Okay. Then how you represent 1 by 3? It is very simple. 1 by 3 means it is the one part of the 3. So suppose it is the 0, it is the 1. You have to break the space between 0 and 1 into 3 equal parts. That is 1, 2, 3. All these are having same equal distance. So this part we call as 1 by 3. This part we call as 2 by 3. This part we call as 3 by 3. If you clearly see, 3 by 3 is nothing but 3 ones are 3. That is 1. That's why here it is 1. Okay. So In this way you can represent 1 by 3, which is between 0 and 1, so it is on the right side. Similarly, minus 1 by 3, it is on the left side, and minus 1 by 3, and it is equal distance from this side. How much? The distance between 0 and 1 by 3 must be equal to distance between 0 and minus 1 by 3. Okay, like that. Okay, students. So in this way you can represent rational numbers on a number line. Okay, here 1 minus 1 by 2, here it is the 1 by 2, and if you can take minus 3 by 2, so if you want to represent 3 by 2, that will be 3 by 2 will be 3 by 2 must be between 1 and 3. Sorry, 3 by 2 is between simply now 0, 1, 2. Then where is 3 by 2? 3 by 2 is between 1 and 2, so 3 by 2 it is here, 3 by 2. Then where is minus 3 by 2? Minus 3 by 2 is same distance. How much distance it is? How much distance? Same distance, so it is here. So like that we are going to represent rational numbers on number line. So we have completed the third topic also. We are completing the third topic also, students. Now we are entering into the fourth topic. What is the fourth topic? Fourth topic is rational numbers in standard form. Rational numbers in standard form. What is the standard form? Standard form. Standard form. Basically the denominator of these rational numbers, just see these rational numbers, observe these rational numbers. What are those? 3 by 5 and 2 by 7 and minus 7 by 11. So observe these rational numbers. If you clearly observe that the denominators of these rational numbers are positive integers, so all the denominators are positive. It is positive, it is positive, it is positive. Denominators are positive, and 1 is the only common factor. So the only common factor between numerator and denominator is 1 only. 1 only. We can write this as 3 into 1 and 5 into 1. That's it only. There is no another common factor. Suppose if you have 4 by 6, how we can write as? You can write as 2 into 2, 3 into 2. So here what is the common factor? 2 is the common factor for these two, and we can written this also as 4 into 1, 6 into 1. So 1 is also common factor to both numerator and denominator. 2 is also common factor to numerator and denominator. But in this case of 3 by 5 and 2 by 7, I will rub all this. In the case of 3 by 5 and 2 by 7 and minus 7 by 11, there is only one common factor, that is 1. We can write as 3 into 1, 5 into 1. That is only one common factor. But in the case of 4 by 6, it is having 2 also as the common factor. This for this also 1 is only the common factor. For this also 1 is only the common factor. So what is the both conditions? The first condition is the positive integers. The next condition is the common factor. The common factor is 1. Only 1 is the common factor. So further, the negative sign occurs in the numerator. Further thing is negative sign in the numerator. And negative sign in the numerator. So we called such type of rational numbers as standard form. We called such type of rational numbers. We call those as in standard form. So basically a rational number is said to be in standard form. When will we say that rational number is in standard form? If its denominator is a positive integer and the numerator and denominator have no common factors other than 1. Okay, when standard form, what are the conditions for a standard form of a rational number? It is very simple. First condition is 1 is only common factor. So both the numerator and denominator must have one and only common factor. No other common factors for numerator and denominator. What is the another condition? Denominator must have positive integers. What it is? Positive integers. Denominator has positive integers. So denominator is positive integer and common factor only one. If these two conditions are satisfied by any rational number, we call that rational number is in standard form. Okay, if a rational number is not in a standard form, then it can be reduced to standard form. One other thing is some rational numbers are in standard form. If any rational number is not in standard form, we can reduce it to standard form. Basically how we will reduce it means, basically we will reduce it by by cancelling the common factors. By cancelling the common factors. So for example, minus 40 by 45 by 50. How you can convert or reduce it to rational form? Very simple. If what are the factors for 45? We can write 45 as 45 divided by 3. We can divided by 3. And by one thing is you have to divide both numerator and denominator with the same number. So what happens? That will becomes 15. This will becomes 10. Again with the same number you have to divide. Again you are dividing with 15 by 5, 10 by 5. Again what will becomes? It is 3 by 2. There is negative sign. So this is final number is minus 3 by 2. How you will reduce means you have to divide both numerator and denominator with the same number. So finally it becomes 3 by 2. So does 3 and 2 have any other common factors except 1? No. 1 is the only common factor. So this is satisfied. And another thing is denominator is positive integer. So this is in the standard form, but this is not in the standard form. Why? Because even though it is having positive denominator, it is having common factors other than 1. So but it is not having any common factors. So in this way you can reduce any rational number into standard form. That's it, students. We have completed the 4th topic. Now we are entering into the 5th topic, that is comparison of rational numbers. How we will compare rational numbers? Okay, basically suppose our aim is to two positive. Suppose we have to compare suppose you have to compare 2 by 3 and 5 by 7. How you will compare? Basically, if you want to compare any rational numbers, by representing it number line, you can easily compare. So in order to represent in number line, you have to make the denominators must have same number. For example, this is 2 by 3 and this is 5 by 7. We can't compare both, but we can simply compare 2 by 3 and 5 by 3. Why? Because it is having same denominator. So simply comparing the numerators, we can guess or decide which is greater, which is less. So for this reason, what you have to do? We have to get denominators same, equal. So what we can do? Simply multiplying these with any other numbers will give the 2, so that to get same number. Suppose you will multiply with 2 with multiply with 7, then what will the value? 7 2s are 14, 7 3s are 21. And about this number, if you multiply with 3 on both sides, what is the number? 5 3s are 15, 7 3s are 21. So finally, what is the numbers we are having? So denominator is same. So if you consider the numerator, it is the 14 and it is the 15. So simply we know that 14 is less than 15. So hence 15 by 21 is greater than 14 by 21. So if you have the same denominators, then you can easily compare to rational numbers. Okay, for that you have to get the same, you have to modify your rational numbers, given rational numbers, to that they must have same denominators. For example, if you want to compare minus 1 by 2 and minus 1 by 5, so for that you can use number line also. So you have to represent both these on number line. So basically in the number line, the numbers which are on the right side of the number line are greater than the left side of the numbers on the left side. So for that reason, the numbers which are on the right side of the number line are greater than the numbers which are on the left side of the number line. So for that you have to represent minus 1 by 2 and minus 1 by 5 on the rational number. Okay, on the number line. So we can write minus 1 by 2 as the minus 5 by 10 by so minus 1 by 2, we have multiplied both sides with 5 and 5. So how it becomes minus 5 by 10. So we get minus 5 by 10 as minus 1 by 2. Now another thing is minus 1 by 5. We are multiplying it with 2 on both sides. So minus 2 by 10. So what are the values we are finally getting? We are getting minus 5 by 10 and minus 2 by 10. So what is the location of minus 5 by 10 and minus 2 by 10 on the number line? Basically on the number line, negative values are always on the left side. So 0 and to the left side, and and denominator is 10. So what we can do means which is minus 2. So from moving from 0, you will get, after 0 you will get 1 2, after 0 you will get 1, after 1 you will get 2. So here is the minus 2 by 10. Minus 2 by 10 is nothing but minus 1 by 5, and after crossing 2 you will get 3 4 5. So finally here you will get minus 5 by 10. Okay, so in this way, if you observe, this is the minus 5 by 10, this is the minus 2 by 10, then which is greater than, according to rules on the number line, which is on the right side, it is the greater than the left side number. So it is the greater than number, which is minus 2 by 10 is the greater number. So minus 2 by 10 is nothing but minus 1 by 5. So it is the greater number. It is the greater number. Okay, in this way you can find, compare rational numbers. One more another thing is, basically we know 2 is greater than 1, 3 is greater than 2, like that. So but whenever the case is negative symbols, minus 2 is less than minus 1, minus 3 is less than minus 2. Why? Because basically whenever there is positive sign, 2 greater than 1, but whenever there is negative sign, what you have to do is just what you have to do is, whenever there is negative sign, if there is no negative sign, which is greater, 2 is greater than 1, when if there is no negative sign. So write like that, and whenever there is a negative sign, just reverse the order, that's it. That minus 2 is less than minus 1, like that. If you can't understand, I will explain you clearly one more time. Suppose basically if you have 2 and 3, which is greater than, 2 is less than 3, but you have to compare minus 2 and minus 3. Normally 2 is less than 3. Normally 2 is less than 3. Just write it, and whenever you are having minus symbols, just reverse this order, which means just reverse this sign when the case there is minus. So minus 2 is greater than minus 3. That is the first thing. The case of pair of negative rational numbers is similar. To compare two negative rational numbers, we compare them ignoring their negative signs and then reverse the order. Simply reverse the order. Here minus 7 by 5, minus 5 by 3. We have to compare both these numbers. But first what you have to do, first take them as the positive integers like minus 7 by 5 and 5 by 3. So in the case of 7 by 5 by 3, 7 by 5 3 is less than 5 by 3. So in this case what you have to do, just this is the case when there is positive sign. So when there is a negative sign, just change this order. So you have to write this like that. So then what happens, minus 7 by 5 is the greater than minus 5 by 3. This is the case of when two negative fractions, negative rational numbers. This is the case whenever there is two negative rational numbers. Okay. So if you want to compare two negative rational numbers, this is the case. And if you want to compare one rational number, one negative rational number, one positive rational number, it is very easy. Why? Because positive rational numbers are always greater than the negative rational numbers. That's it, students. We have completed the fifth topic also. Now we are entering the sixth topic. What is the sixth topic? Rational numbers in between rational numbers. Rational numbers between rational numbers. Between rational numbers. So basically minus 3 by 5 and minus 1 by 3. These two are the rational numbers. So these two rational numbers can be written as, suppose if you multiply it with 3 on both sides, minus 3 into 3, 5 into 3, then it will becomes minus 9 by 15. And again this with 5 on both sides, minus 1 by 5, 3 by 5, that will becomes minus 5 by 15. So finally these numbers has transformed into these numbers. So minus 9 by 15 and minus 5 by 15. So if you clearly understand, this is the 15, this is the 15, and this is the minus 10, this minus 5, then what are the numbers between these? Those numbers are, we can simply guess, that is minus 9, there will be minus 8, minus 7, minus 6. So minus 8 by 15, minus 7 by 15, minus 6 by 15. So these three are the rational numbers between these two rational numbers. So these three are the rational numbers between these two rational numbers. So only these two are the rational numbers between these two rational numbers? Not at all. We can increase those. So how for example, I will give another example. So suppose minus 3 by 10 and minus 6 by 10. Basically, how many rational numbers? That is minus 4 by 10, minus 5 by 10. These two are the rational numbers between these two rational numbers. But now what I will do, this way I will transform this by multiplying both sides on numerator and denominator with the 10. So that then it will becomes minus 30 by 100. This will becomes minus 60 by 100. So if you know, see, these rational numbers are equivalent to these rational numbers, then what are the rational numbers between these two rational numbers? This is 30, this is 60. There are almost 30 rational numbers, that is minus 31, minus 32, and so on, minus 59. So almost 30 rational numbers in between these two rational numbers. So how crazy it is, no? So only 30 rational numbers. If you multiply this with again with the 10, what happens? It will becomes 300. It will becomes 1000, and it will becomes minus 600. It will becomes 1000. Then what are the rational numbers between them? In between them there are almost 300 rational numbers. Here there are almost 30 rational numbers. Here we are having only 2 rational numbers. So if you further multiply with another 10, then it will becomes 3000 rational numbers. So finally, how many rational numbers are there between two rational numbers? Between there are infinite. There are infinite, as many infinite rational numbers are there in between two rational numbers. We can write so many rational numbers in between two rational numbers. So we can find unlimited. There is no limit for that. Unlimited number of rational numbers between any two rational numbers. That's it, students. We have completed that topic also. Now we are entering into the 7th topic, that is operations. What is the 7th topic? Operations. What are the operations on rational numbers? What are the basic operations on rational numbers? Rational numbers. Okay, basically, what are the mathematical operations? Addition, subtraction, multiplication, division. So first thing is addition. So how to add two rational numbers? It is very simple, I think, but somewhat difficult. So suppose 7 by 3 you have to add with minus 5 by 3. So how to add? Suppose if you take help of a number line, you have to add 7 by 3 with minus 5 by 3. What you have to do? First you have to locate the position of 7 by 3. So where it is the position of 7 by 3. Basically in the addition, what you have to do, you have to take this much of steps to the right side if there is positive, but here it is negative. So you have to take this much of steps to the left side. How many steps you have to take? In the numerator it is 5, so you have to take 5 steps, and it is the negative symbol, so you have to move left side. So starting from here, 5 steps. 1, 2, 3, 4, 5. So finally, what is the result? What is the number we have got? The number is 2 by 3. So 7 by 3 minus 5 by 3 is nothing but 2 by 3. So this is the simplification process. If you clearly observe, if both denominators are same, so you can write as 3, and 7 minus 5, that is also equal to 2 by 3. So how you will add rational numbers means it is very simple. If both denominators are same, then you can simply write that number in the denominator and subtract or add the both denominators and write the result. For example, another example. Suppose 1 by 4 plus 6 by 4. How you will add? Basically denominator is same, so just simply write that number on the denominator, and in numerator what you have to do, you have to add both these. So 1 plus 6, so that is 1 plus 6 means 7 by 4, like that. Suppose subtraction is also similar. Suppose we have to subtract 1 by 4 minus 6 by 4. What you have to do? Just denominator is same, so you have to just write the 4, and 1 minus 6 you have to write the both terms in the numerator. That is 1 minus 6 is minus 5 by 4. So whenever the denominator is same, the addition and subtraction are same and very simpler, just adding or subtracting the numerating terms. But whenever the denominator is not same, what you have to do? You have to find the LCM. Like that. Okay, you have to find the LCM, and that you can find, or you have to convert those rational numbers into the having that same denominator, or you have to rationalize them. That is the best thing. So we find that while adding rational numbers with the same denominators, we add the numerators keeping the denominator same. Just we add numerators by keeping denominator same. This way what we have find out in the addition. And another concept like in this is additive inverse. So what happens if you add minus 4 by 7 to 4 by 7? Basically these both are having same denominator, so 7, and you have to add both these, that is minus 4 plus 4, that is nothing but 0. So whenever we add one rational number to another rational number, in many cases you will get another number. But if you add two rational numbers, you are getting 0. Then we called both these are additive inverse to each other. Both these are additive inverse to each other, and 0 is the additive inverse. And we called minus 1 by 4, sorry, not minus 1 by 4, here minus 4 by 7 and 4 by 7 are additive inverse to each other, additive inverse to each other. Why? Because means they are opposite, they are inverse. Why? Because means whenever we are adding those, we are getting 0. So for rational numbers, we call minus 4 by 7 as the additive inverse of 4 by 7 and 4 by 7 as the additive inverse of minus 4 7. So what is additive inverse means? Whenever we add two rational numbers, then you get answer 0. Then both the two rational numbers are called as additive rational numbers of each other. So next thing is subtraction. Subtraction is a very simple whenever the denominator is same. But whenever the denominator is not same, what we have to do? Suppose example 5 by 7 and 3 by 8. You have to subtract them. What you have to do? In these cases, whenever the denominator is not same, you have to find the LCM. So LCM for 7 and 8 is 56, and you have to multiply 8 5 times, that is 50, and you have to multiply 7 3 times, that is 21. So final answer is 19 by 56. So one simple thing is just if the denominator is same, just subtract the numerator. If the denominator is not same, find the LCM and subtract and do as per the LCM. Subtract the numerators by finding LCM. That is the subtraction in rational numbers. That is subtraction in rational numbers. So we say while subtracting two rational numbers, we add the additive inverse of the rational number that is being subtracted to the other rational number. Okay, that it is. Now we are doing into the multiplication. That is the third application. How we will multiply? Basically, whenever you are doing multiplication on number line, how you will do? Basically, if you want to multiply minus 3 by 5 by 2, multiply by 2, what you will do? First you start at origin. So you start at origin, and you have to take two steps, and each step size is minus 3 by 4. So from it you have to find out 3 minus 3 by 4. It is the first step, and the second thing is the minus 6 by 4. This is the next step. So finally answer is minus 6 by 4. So simply if you clearly observe that how you can multiply rational numbers means, suppose there is 3 by 5, and if you and into 2, how you will multiply means simply multiplying the number with multiplying the other number with numerator. You can easily get the answer. Minus 3 into 2 and 5, that is equal to minus 6 by 5. Okay. So we find that while multiplying a rational number by a positive integer, so here what is the case? Multiplying a rational number with a positive integer, we multiply the numerator by that integer. Simply you are multiplying the positive integer with the numerator of the rational number, keeping the denominator unchanged. We don't change the denominator. That's it, students. In this way you can multiply rational number with a integer. So step 1 is multiply the numerator of the two rational numbers. So as we did in the case of fraction, we multiply two rational numbers in the following way. So, but how you have to multiply two rational numbers, suppose 2 by 3 and 5 by 7? That is very simple. What is the step 1 is multiply the two numerators, that is 2 into 5, and multiply the two denominators, that is equal to 3 into 7. So finally that is 5 into 2 is 10, and 7 into 3 is 21. In this way you can multiply. అంటే very simple thing, just multiply both numerators and write in the numerator, multiply the both denominators and multiply in the denominator. That's it. That is the case in the multiplication of rational numbers. And what is the division? About division in the rational number. So in the case of division, what we get is that is reciprocals. Basically, suppose 1 minus 1 9 4 by 9 is there. Suppose if you multiply this with 9 by minus 4, what is the answer? The answer is 9 and will cancel, minus 4 minus will cancel 1. We will get the 1. So then now we called minus 4 by 9 is the reciprocal of minus 4 by 9 is the reciprocal of minus 4 by 9 is 9 by minus 4. So if you want to find the reciprocal of any number, we have to just you have to interchange numerator and denominator. Here 9 is in the denominator, we have taken it into numerator, and here minus 4 in the numerator, we have taken it into the denominator. So just interchanging numerator and denominator, you will get the reciprocal of any number. Suppose 2 by 3, then tell what is the reciprocal of this number. It is very easy. Just change the denominator to numerator, numerator to denominator. That is 3 by 2. And another thing, now tell me the numerator of what is the reciprocal of 10 by 7. Very simple. You have to interchange 7 by 10. What is the reciprocal of minus 1 by 9? It is very simple. Interchanging 9 by minus 1. So I think you are able to understand what is reciprocal is. So in the doing the division of a fractional numbers, we want reciprocals. Suppose we have to multiply or we have to divide 4 by 9. We have to divide 4 by 9 with minus 5 by 7. What you have to do? First, what you have to do is you have to find the reciprocal for the second number. Reciprocal for the second fraction. The reciprocal of minus 7 is what? Simply interchange the numerator and denominator. That is 7 by minus 5. Now what is the second step you have to do? After finding this is the first step, you have to find the reciprocal. What is the second step? Multiply fraction and reciprocal. Fraction and first fraction and second reciprocal of second. Reciprocal of second fraction. Very simple, guys. Just wait a second. What is the first fraction? That is 4 by 9. And what you have to do? We have to multiply it with what? With the reciprocal of the second fraction. This is the second fraction. The reciprocal of the second fraction is 7 by minus 5. 7 by minus 5. So now what we have to do basically is the multiplication. We know how to multiply two fractions. It is very simple. Multiply the numerators, that is 7 into 4, divided by multiply the denominator, that is 9 into minus 5. That what is the 7 4s are 28, 9 minus and 9 5s are 45. So that is minus 28 by minus 45. That is the answer. You can take this minus symbol to numerator. So this is the simple way you have to do while multiplying rational numbers, so dividing rational numbers. Thus this shows that to divide one rational number by the other non-zero rational number, we multiply the rational number by the reciprocal of the other. We have to find the reciprocal of the second rational number, and you have to multiply the first rational number with the reciprocal of the second rational number. That's it, guys. We have completed our chapter completed. And what next? We are going to have the summary of the whole chapter. What are the 7 concepts we have learned until now? We will have the summary, quick summary. So basically, rational numbers is the chapter. It is having 7 topics. So first topic is the what are rational numbers. The numbers which are in the form of p by q form are called rational numbers, and p and q are must be integers and q not equals to 0. These are the 3 conditions for a rational number. And what is numerator and denominator? So the one which is in the upside of the dash is the numerator, and one is which in the downside is called denominator. And next one is equivalent rational numbers. So one rational number can be written in other forms with different numerator and denominator. Basically, minus 2 by 3 by multiplying both numerator and denominator with same non-zero integer. By multiplying both numerator and denominator with same non-zero integers, we get different rational numbers which with different numerators and denominators. But both these rational numbers are same. Are same because we are multiplying numerator and denominator with same factor, same common factor, same non-zero integer. So next we have completed the first topic. Second topic is positive and negative rational numbers. Like integers also we are having positive rational numbers and negative rational numbers. So what are positive rational numbers? Positive rational numbers are rational numbers which are having numerator and denominator positive, numerator and denominator positive, numerator positive, denominator positive, then positive rational numbers. Then what are negative rational numbers? Denominator positive, numerator negative, those are negative rational numbers. If their numerator negative, denominator positive, those are negative rational numbers. We completed that topic also. How to represent rational numbers on a number line? Simply, basically you have to suppose you have to represent 1 by 2, it must be on the 0, it must be halfway between the 0 and 1. So you have to represent positive rational numbers to the right side of the 0, and you have to represent negative rational numbers left side of the 0. What you have to do is, you have if your fraction is 1 by 2, then you have to make the distance between 0 1 into two parts, and first part is 1 by 2, second part is 7 by 2. If you want to represent 1 by 3, and you have to make the distance between 0 and 1 into 3 equal parts, and first part is 1 by 3, second part is the 2 by 3, like that you will represent rational numbers on number line. Okay students, next thing is fourth topic, that is rational numbers in standard form. So what is the standard form? What is the standard form for a rational numbers? So if the rational number is having both the numerator and denominator is having only one common factor, that is 1, only one common factor, that is 1, and denominator is positive integer, then it is in the standard form. Example is minus 3 by 2. 3 and 2 are having 1 as the only one common factor, that is 1. But minus 40 by 30 are having 3 as a common factor, 5 as a common factor. So this number is not in a standard form. But minus 3 by 2 is having 1 as a common factor and no other common factors, and denominator must be positive. If anything satisfies these two conditions, then it is in standard form. And then next thing is comparison of rational numbers. How we will compare rational numbers? Basically, if you want to compare two rational numbers, the denominator must be same. Then by comparing a numerator, we can simply compare the rational numbers. Okay. And in the case of number line, the numbers which are on the right side on the number line are greater than the numbers which are on the left side on the number line. So if you want to compare two negative integers, just first compare both those integers, treat those integers as the positive integers, and after finding which is greater than, which is less than, just after that we have to change the order. You have to reverse the order. Then you will get which is greater than, which negative number is greater than other. And how to compare a negative rational number and positive rational number? Basically, positive rational number is always greater than the negative rational number. And the sixth topic is rational number between rational numbers. We can find so many infinite, unlimited number of rational numbers between rational numbers. Why? Because means basically in minus 9 by 15, minus 5 by 15, only 3 rational numbers are there. In the same case, minus 3 by 10, minus 6 by 10, only 2 rational numbers are there. But if you multiply both numerator and denominator with 10 for this number, these numbers will be on the another form. These are there in the with having separate numerator and denominator. Then there are so many numbers between these two rational numbers. In this way, you can get a lot of rational numbers between rational numbers. And the next thing is the operations of rational numbers. That is the most important, addition. If the denominator is same, just add or subtract the numerators. That's it. If denominator is not same, just find the LCM. In that way, you can add or subtract the rational numbers. That is about the addition and subtraction of rational numbers. And additive inverse. If the addition of any two rational numbers is 0, then those two rational numbers are called additive inverse to each other. And another thing is the multiplication. How we will multiply means, just if you want to multiply a rational number with a integer, just multiply the numerator of the rational number with the positive integer. That's it. If you want to multiply two rational numbers, then first you have to do multiply both numerators, and next multiply both denominators. That's it. You can get the final result. And division, before doing division, you have to know about the reciprocal. If you multiply two numbers, then the answer is 1, then we call that those two are the reciprocal to each other. If you want the reciprocal of any number, how can you will get? Simply by interchanging the numerator and denominator, you will get. Suppose 10 by 7, 10 by 7, then if you interchange numerator and denominator, that is 7 by 10, it is the reciprocal. So how you will divide using two fractional numbers? So it is very simple. If you want to divide two rational numbers, first find the reciprocal of the second number. Reciprocal of the second number, and say this is the first step. And what is the second step? We have to multiply the first fraction with the reciprocal of the second fraction. Multiply the first fraction, that is 4 by 9, and the reciprocal of the second fraction. Reciprocal is the 7 by minus 5. 7 by minus 5. That's it. Then it will becomes the multiplication of two rational numbers. It is very easy. Multiply numerators, multiply denominators, then you will get the answer. So that is about the division in the case of rational numbers. That's it, students. Our chapter completed, our summary also completed. So have a nice day. Keep learning, keep smiling. Bye bye.